O, kita nyo ba? Does my screen is visualize or fit in your screen for you to read those uh, written on the slides? Kita nyo ba?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So for this morning, we are dealing with the footings. Okay. So footings are the structural elements that transmit column or wall loads to the underlying soil below the structure. No? So it was discussed in our video presentation. Okay. Footings are designed to transmit these loads to the soil without exceeding its safe bearing capacity. So if that will happen nga, it would be undergo the bunching effect. Okay? So it was stated in the video presentation yan naman. Okay. So to prevent excessive settlement of the structure to a tolerable limit or to minimize differential settlement and to prevent sliding and overturning, the settlement depends upon the intensity of the load. Okay? Yung settlement na nangyayari sa ating that's sa ating building ay magdedepende po sa mga loads na binibigay ng inyong building or yung sa inyong structure. So it can be the one you should consider is the type of soil and the level of your foundation. Okay? Where possibility of differential settlement occurs, the different footing should be designed in such a way to settle independently of each other. So you can be design a square footing, rectangular footing, trapezoidal footing, strip footing, okay, or strip foundation. Okay? So foundation design involves a soil study to establish most appropriate type of foundation and a structural design to determine footing dimensions and required amount of reinforcement. So if you're designing a footing, there is also a corresponding number of your reinforcement so that it would be a good enough to carry the loads in your building. Okay? So, because of compressive strength of the soil is generally much weaker than that of the concrete, the contact area between the soil and the footing is much larger than that of the columns and walls. Okay? So, the footing types. The type of footing chosen for our particular area is affected by the following. Or you should consider this following if you design the footing so that you can determine what type of the footing to be designed. Okay? So the first one is the bearing capacity of the underlying soil. Okay? So take note that it should not the stress should not exceed the soil bearing capacity. Okay? The second one is the magnitude of the column loads. The third one is the position of your water table. No, it is not possible that your footing will be put on the water table mismo. No, it can add some effects to your footing, and eventually it can affect also your foundation or your building or your structure. Okay? And then the fourth one is the depth of your foundation of adjacent building. So dapat alam mo yung depth ng foundation nung kabilang structure na nakatabi ninyo so that alam nyo kung ano yung ide-design yung foundation para hindi naman siya matatamaan dun sa foundation or dun sa footing ng kabilang structure. Okay? Maliwanag ba? Maliwanag ba?
Yes, sir.
Yes, sir.
Okay. If you have questions, you can, what do you call that? Ask, ano? Para sa ganon, yung ibang classmates ninyo ay malinawagan din kung or ma-add sa idea nila yung mga pinagtatanong natin. Okay? So, footings may be classified as a deep or shallow. What is the difference of the two? Yeah. So, if the footing is a deep, no, or it was classified as the deep footing, no, the depth its depth should be equal or greater than to its width. Okay? Yung kanyang lalim ay mas malaki or equal lang sa width ng inyong footing or yung kanyang haba. Okay? Otherwise, it should be a shallow footing. Okay? Kung ang depth ng footing ninyo is less than or equal to the width, so it could be a shallow footing. Okay? So this is the illustration of an isolated footing. So you applied a force P and into the to the footing, and then the h, it would be the thickness of your footing, and the L, it would be the width of your footing. Sometimes most of the time the letter L there is denoted as letter B. You can see in this figure, letter B. Okay? And sikat yan yung letter B sa questions or sa board examination questions. So, the first one is the square footing because its length and width is equal. And the other one, it is a normally rectangular isolated footing. Okay? So, the isolated footing is used to support the load on a single column. Okay, good morning, Engineer Pamitan.
Good morning, sir. Sorry, late.
Okay, okay. It is usually either square or rectangular in plan, yung inyong isolated footing. So, it represents the simplest and most economical type and most widely used footing. So, these type of footing are the one used in the what do you call that, in the construction. Okay? Mas sikat silang ginagamit, and syempre as a engineers, we also consider its economically effect. Tama ba? Na kung mas economical siya, yun yung mas gagamitin natin. Basta it would be a safe for the building. Okay? So whenever possible, square footing are provided so as to reduce the bending moment and the shearing forces of their critical sections. No? Yun nga, mas maganda din yung square footing para sa ganon, it will reduce those effects. Good morning, Engineer Adun. Okay. Isolated footing are used in Isolated footings are used in case of a light column loads. When columns are not closely spaced, and in case of good homogeneous soil, under the effect of upward soil pressure, the footing bends in a dish shape form. Sorry. An isolated footing must therefore be provided by two sets of reinforcement bars. Okay? Placed on the top of the other near the bottom of the footing. In case of the property line restrictions, okay? Kapag lumampas ang inyong footing with your property line and nakapasok siya to the property line of your neighbors, okay? The footing may be designed for eccentric loading or combined footing. Okay? So, yung in the edge of your footing that was designed, no, to prevent from exceeding to your property line, the footing will be moved to the edge of your property line. Doon lang siya sa property line mo. Pero yung kanyang poste, it would stay the same. No? Kung ang inyong poste ay tumama mismo sa property line, at ililipat mo ang inyong footing, the poste would stay the same, no? And ang possibility na gagawin mo diyan to calculate the loadings, no? Or to calculate the effects, to determine the effects, then the loadings should be solved with eccentrically loaded. Or you can use a combined footing. Okay? So, in figure 11.1, nasa taas, it shows the square and the rectangular isolated footing. Okay. So, we go now to the depth of the footing. So, the depth of the footing which foundation should be carried is to satisfy the following considerations. There are so many considerations if you design footing for us that our footing design footing would be safe for our building. The first one is to ensuring the adequate bearing capacity. Okay? Paulit-ulit natin itong sinasabi yung kanyang bearing capacity. Okay? It should not exceed, no? So the stress should not exceed with the soil bearing capacity. Okay? The next one, in the case of a clay soil, no? Footings are to penetrate below the zone where shrinkage and swelling due to seasonal water changes are likely to cause appreciable movement, no? Gaya nga ng sabi ko kanina, if you put your footing on the water table, no? It can show some effects, no? Pero it would be a light effect or it could be a serious effect. Okay? The footing should be located sufficiently below the maximum scoring depth. No? Makikita natin mamaya doon sa next discussion natin of what depth to be considered, no? During the designing of the footing. No? Meron kasing minimum depth of the footing and then meron ding range nung kanyang footing, depth of footing. Okay? That the fourth one is the footing should be located away from the topsoil containing organic materials and also from unconsolidated materials such as garbage, no? So kapag ganyan, it could be the soil will be a what do you call that? Malambot. Malambot yung soil, soft yung soil para makapag-handle siya doon sa design footing mo. Okay? So, kailangan i-place mo siya, your footing should be placed away from these consideration, from these criteria. Okay? All footings shall extend to a depth of at least 0.5 meters below the ground level or the natural ground level. Ito na nga po yung sinasabi natin kanina na if you consider the depth or if you design for the depth of the footing, it should be 0.5 below 0.5. Okay. On a rock or such other weather resisting natural ground, removal of the topsoil may be all that is required. In such a case, the surface should be clean, no? Kapag may mga rocks or other resisting natural ground, kung ano yung mga distractions doon sa taas ng inyong soil, it should be clean, no? So that kasi makaka-epekto ito sa ating footing. Okay? So as to provide a suitable bearing. Okay. Usually, footing are located at a depth of 1.5 to 2 meters below our natural ground level. Okay. So the pressure distribution below the footing. So the distribution of soil pressure under the footing is a function of a type of a soil. So it is a relative rigidity of the soil and the footing. So, and the depth of the footing or the depth of the foundation at level of contact between the footing and the soil. Okay? A concrete footing on a sand will have a pressure distribution similar to figure 11.2. Andito yung distribution niya, oh. Dito sa baba. So, kapag nakasand, nilagay sa sand ang inyong footing, the distribution, it could be a concave upward with respect to the footing. Okay? Kapag nakalagay naman siya sa clay, it would be a concave downward. Okay? If sa normal lang na soil, nilagay ang inyong footing, it would be a equivalent uniform distribution. Okay? Yun na. So when a rigid footing is resisting on a sand soil, the sand near the edges of the footing tends to display laterally when the footing is loaded. No? So it tends to decrease in soil pressure near the edges of your footing. Kita nyo naman, mas malaki ang pressure dito sa kalagitnaan ng inyong footing kaysa doon sa edges or sa gilid ng inyong footing. Okay? So in figure 11.2 point B, it is a footing or the distribution under a footing on a clay, no? Sa clay naman siya. Gaya ng sabi ko kanina. Okay? And the footing is loaded, no? Kapag niloload na ang footing in a clay soil, so the tendency, the soil under the footing deflects in a bowl-shaped depression, no? Ito na yung concave downward niya, no? Relieving the pressure under the middle of the footing. For design purposes, it is a commonly assumed the soil pressure are linearly distributed. So mostly sa design, ito na yung kino-consider natin. In actual, it would be like this, no? Ganito yung kanyang distribution, yung letter A and letter B. But for designing, they prefer to use a linearly distributed pressure. Okay? The pressure distributed will be uniformly if the centroid of the footing coincides with the resultant of the applied loads as shown in 11.2. Okay? So, the next one, the ultimate bearing capacity. So, the ultimate bearing capacity is always denoted as QU. Q subscript U. No? So, we call it as an ultimate bearing capacity if the maximum density of a loading at the base of the foundation which causes shear failure of the soil. No? And then the other hand, the allowable bearing capacity of soil, it is the intensity of loading that the soil carries without causing shear failure and without causing excessive settlement, no? Kapag ang soil natin ay nag-cause or kapag ang foundation natin ay may cause of shear failure, it would be a ultimate bearing capacity, no? Pero kapag without causing of shear failure, no, or excessive settlement, it would be a allowable bearing capacity of soil, no? Kung ang ultimate bearing capacity is denoted as Q subscript U, sa allowable bearing capacity naman, it will be denoted as Q subscript A or Q subscript all. ALL, short for allowable. Okay? So, it should be denoted QA in a service load stress. Mhm. So, the allowable bearing capacity of soil is obtained by dividing the ultimate bearing capacity, so yung QU mo daw, by a factor of safety over Fs, yung tinatawag nila. So, therefore, yung ultimate bearing capacity mo in relation with the factor of safety, if the factor of safety is given, QU is equal to the QA over Fs. Okay? Mostly the factor of safety that was given is ranging from 2.5 to 3. Okay? There is no unit for this factor of safety. Okay? So the allowable soil pressure for soil may be either gross or net pressure permitted on the soil directly under the base of your footing. Okay? The gross pressure represents the total stress in the soil created by the load above the base of your footing. So these loads, it would be include the column service loads, the weight of your footing, and also the weight of the soil on the top of your footing. So it could be derived as Q gross, or the bearing capacity gross is equal to the bearing capacity of the soil plus the bearing capacity of the footing and plus the bearing capacity of the column. So if you sum up all this, it could be derived with the soil, with would be the bearing capacity gross. Okay. For the moment and shear calculations, no, the upward and downward pressure of the footing mass and the soil mass get cancelled, no? For yun nga, they don't consider the moment and shearing calculations for this ganun. Pero in real life, there is a moment and these shearing effects. Okay? So the net soil pressure could get as Q net is equal to the Q gross minus the Q of the footing minus Q of the soil. Okay? So this figure would present the computations yung kanina na pinagbabanggit ko. Okay? The Q of the soil, i-add mo sa Q ng concrete, i-add mo sa Q ng column, makukuha mo si Q all gross or the Q allowable gross. Okay? Dito naman sa pangalawa, si Q allowable net ay makukuha mo siya kapag si Q allowable gross ay binawasan mo kay Q ni soil at Q ni concrete. Okay? The next one, the concentrically loaded footing, no? If the resultant of the loads acting at the base of the footing coincides with the centroid of the footing area, no? The footing is concentrically loaded and uniformly distributed of soil pressure is assumed to design. You can see it on this figure, no? Nandiyan na yung kanyang moment, ang kanyang eccentricity, which can be derived as the moment over the pressure that was applied. And then, kokontrahin naman siya sa baba ni bearing capacity. That could be the pressure over the area of your footing. No? Naintindihan ba? So, the magnitude of the pressure could be the Q is equal to pressure over the area or the load over the area. Okay. So, for designing of isolated footing, wait, okay. For designing of isolated footing is detailed in the following steps. No? Kapag magde-design ka ng footing, may kailangan kang steps na sundan or kailangan kang ay consider. Okay? The first one is to select the trial footing depth. Hanapan mo muna ng lalim or mag-isip ka muna ng kanyang lalim, possible lalim na 0.5 below the natural ground level, no? So, according to ACI code 15.7, the depth of the footing above reinforcement is not be less than 1.5 cm for footing on soil, no? And then nothing that 7.5 centimeter of its clear concrete cover. I know that you already know what this clear concrete cover has mean, no? Kasi it was always tackle or binabanggit ito during your reinforced concrete or in steel design maybe or in the soil mechanics one. I don't think so sa soil mechanics one. Okay? So, if concrete is cast against soil, the practical minimum depth is taken as 25 centimeters. So, medyo malalim na rin. Okay? So, yan na. To establish the required base area of the footing, no? Diyan mo na makukuha sa Q allowable net. So, saka na natin to i-ponder pa or palawakin pa natin yung knowledge natin diyan soon sa next discussions natin. Okay? So, to get the area, no? That was required, no? It could be derived as the load, the dead load plus the load from the live load over the Q allowable or the soil bearing allowable net. Okay? So the sa PD and PL, they are the service dead load and live load respectively. No? Sometimes you would use a 1.4, 1.6, 1.1, and 1.7. So, maintindihan nyo naman yan. I think you was applied in the design. No? Laging nilalagay yan sa design. Malimit lang nilalagay sa geotech. Okay? So, for L and B values, it would be possible to use a square footing. No? Mas mabilis na gamitin sa square footing because to achieve greatest economy. No? The third one is to evaluate the net factored soil pressure. No? Ayan na, si 1.2, 1.6, yan yung subscript na pinagbabanggit ko kanina with respect to the dead loads and live loads. No? QU is equal to 1.2 PD plus 1.6 PL over length times B, or for square, it would be B squared. Okay? The next one is check the footing thickness for punching shear. No, yan yung iniiwasan natin, kalimitan, yung kanyang effects of the punching shear. No? Since the large soil are present under footings, high shear stress are produced, and since shear reinforcement is not normally used. Okay? So, yan na yung computations. Hindi na natin yan gaano itakal because it would be on your reinforced concrete. Ito na yun. Or sometimes it would be in your, I think, in your steel designing. Na ganun niya ba to? Are you familiar with this formula, VC? The punching shear force. VC is equal to 0.53 square root of F prime C. Do you familiar ba kayo sa formula na to? Anyone? Familiar ba kayo?
Hindi po, sir.
Hindi kayo familiar. So, siguro, anong topic nyo na ba sa reinforced concrete? Anong topic nyo na sa reinforced concrete? Wala. Hindi, nakalimutan nyo na yung topic nyo. So, I think sa last part ata ng RC to. No, yeah, the consideration sa columns, sa slabs, no? Yun. Columns, slabs, marami pa. Okay. So, the last one is to check the footing thickness for beam shear in each direction. So, yan na. Marami ng considerations yan. So, we will not ponder on these things na. Okay. So, before we go to the next, before we will go to the next topic, I will give time for your break. Break time muna. Saglit. We will back at 9 a.m.